Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for right triangle trigonometry. In this video, I'm going to go through two different examples, two different types of problems involving sine, cosine, tan, and also the reciprocal trig functions, cosecant, secant, and cotan. What will be different about these problems is that the triangles that we're going to build may not necessarily be in the first quadrant. They might be in the second, third, or fourth quadrants. And if they're in those different quadrants, that means that the values of our trig ratios could be negative. They could be positive or negative, depending on which quadrant they're in. And it all depends on what the x and y coordinates are. That's what would make the trig ratios either positive or negative. And in order to figure out which one is which, we can use the saying, all students take calculus. So that's going to be the core of this video. So let's start with our first example here. Let negative 5, 2 be a point on the terminal side of an angle theta in standard position. So I drew a picture to explain all that entire first sentence. We have negative 5, 2 being a point. So I plotted that point. You can see I have an xy axis here. And I plotted that point negative 5, 2. The terminal side that they're describing is really just the hypotenuse. That's what this is. That's your hypotenuse. And you can see the green arrow from starting at 0 degrees, that green arrow takes us to that terminal side. And the acute angle that we would use for our right triangle is going to be the angle between the terminal side and the x-axis. And that's what I label theta. So now, if that's our angle, if theta is our acute angle for our triangle, we have our opposite, we have our adjacent, and we have our hypotenuse sides. And in order to figure out what sine, cosine, and tan are, we're going to have to figure out the lengths of each of those sides. But because we're given the point negative 5, 2, we know that the adjacent is going to be 5. Because we're traveling 5 units in that direction to get to that point. And then we're traveling up 2 units to get to that point. So that's going to be the opposite side. But now we just need to figure out what the hypotenuse is. And in order to do that, we would have to use Pythagorean theorem. And that's what I have written out right over here. You'll see that we get a radical, a rad 29. And I always encourage you to just leave your answer as the radical. Don't bother rounding it because then you wouldn't have an exact answer anymore. So we have rad 29, which doesn't simplify, by the way. So that's what we're going to be using for our triangle here. So now we're going to have to figure out what sine, cosine, tan, and the reciprocals are. So we would use SohCahToa, or the saying, saddle our horses, canter along happily to other adventures. Or you could even use sad old horses control all humans to obtain authority. Those are all popular sayings, but SohCahToa is the most popular. So SohCahToa tells us that sine is our opposite over hypotenuse. So that's going to be the opposite, which is 2, over the hypotenuse rad 29. So you see I have 2 rad 29. And the reciprocal, the cosecant, that's going to be rad 29 over 2. Once you have sine, you can then find the reciprocal function cosecant. So you know that'll be rad 29 over 2. But the problem with the sine, if you look at the sine value, 2 over rad 29, you have a radical in the denominator. And that's not a proper way to leave a final answer. So we would have to multiply the numerator and denominator by that same radical, rad 29. So then the numerator would be 2 times rad 29. And when you multiply rad 29 times rad 29 in the denominator, you get 29. So those would be our final answers. Then we would have cosine, which is adjacent over hypotenuse. The adjacent's 5. The hypotenuse is rad 29. So we would get 5 over rad 29. But notice, it's negative. And the reason it's negative is because of our saying, all students take calculus. That tells us that every trig ratio in the first quadrant is positive. In the second quadrant, only sine is positive. In the third, tan is positive, and in the fourth, cosine is positive. Well, this problem that we're dealing with, negative 5, 2, that point brings us into the second quadrant. And in the second quadrant, only sine is positive, which means that cosine would have to be negative. So that's why I wrote negative 5 over rad 29. And the reciprocal function will also be negative because it's just the reciprocal of it. You don't change the value from positive to negative if you're finding the reciprocal. You just flip it. I also need to point out that because sine is positive, our final answer for sine was 2 rad 29 over 29. That means that the reciprocal of that is also going to be positive. Finally, we have tan. Oh, and I just wanted to mention that we have to rationalize our cosine answer. Multiply the numerator and denominator by rad 29. That's how you get negative 5 rad 29 over 29. So finally, we have tan. Tan is the opposite over adjacent. So the opposite here is 2, the adjacent's 5, so we get 2 over 5. However, because we're in the second quadrant, only sine is positive, which means that tan is going to be negative. The saying, all students take calculus, it just tells you which ones are positive. So by process of elimination, the other ones would have to be negative. So tan is going to be a negative value, negative 2 over 5. And cotan is the reciprocal of that, still negative 5 over 2. All right, let's take a look at our second problem. It's very similar, but the given information, the information that's given to us is a little different. In this case, we're given cosine, so we're given a trig ratio, and that's going to be 5 over 7. And our angle, our acute angle theta, is going to be in the fourth quadrant. So we're going to have to draw a right triangle in the fourth quadrant. One trick that I just want to share with you is, how do you know how to draw your right triangles? Well, these are what we call our bow tie triangles. If you're in the first quadrant, your triangle is going to look like this. If you're in the second quadrant, your right triangle is going to look like this. This is your third quadrant triangle, and this is the fourth. So that's what the right triangles are going to look like if we're drawing them in the different quadrants. And if you take a step back and look at it, it looks kind of like a bow tie. So these are our bow tie right triangles. And we're in the fourth quadrant here, so that's the triangle that we need to draw, this guy. Now the terminal side, that's the hypotenuse. That's 7. That was given to us because the trig ratio we were given was cosine. That's adjacent over hypotenuse. So the hypotenuse is 7, the adjacent's 5. And then we just need to solve for let me move this out of the way. We need to solve for the hypotenuse, which ends up being rad 24. But we can simplify that. That can become 2 rad 6. So if you have a radical that can be simplified, you should always do that. So your answers can be the most simplified. Now the question wants us to find sine. It also wants us to find cotan. So to find sine, we would have to use a SohCahToa, which tells us that sine is the opposite over hypotenuse. So the opposite here is 2 rad 6. The hypotenuse is 7. So that's going to be the value of sine, 2 rad 6 over 7. And the question, it didn't ask for you to find the cosecant, but I wanted to share that with you anyway. The cosecant is going to be the reciprocal, 7 over 2 rad 6. But anytime you have a radical in the denominator, you need to simplify that. And we simplify it by multiplying the numerator and denominator by that radical, rad 6. So now we get 7 rad 6 over 12 for cosecant. I have cosine here. Cosine's 5 over 7. That was given to us. So the secant would just be 7 over 5. And then I have tan. Tan is 2 rad 6 over 5. The cotan would be 5 over 2 rad 6. And then the reciprocal of that. I'm sorry, that is the reciprocal, but we would have to rationalize it, giving us 5 rad 6 over 12. Now, there's one more thing that we left out that we have to address, and that would be all students take calculus. Because some of these trig ratios are positive, some are negative. Because we're in the fourth quadrant, that means that only cosine is positive, which means all the other ones are negative. So one adjustment we have to make for these questions to be correct is to make these negative. So as a reminder, because we're not in the first quadrant where all of them would be positive, because we're in different quadrants, in this case, the fourth quadrant for this problem, we have to pay attention to which trig ratios are positive and which ones are negative. In the fourth quadrant, because all students take calculus, calculus starts with a C, that means that cosine is going to be positive in the fourth quadrant. And that all other trig ratios, the sine, the cosecant, the tan, and the cotan, those are negative. And because cosine is positive, cosine was positive 5 over 7, the reciprocal of cosine is going to also be positive. So if a trig ratio is positive in a quadrant, its reciprocal is also going to be positive. If a trig ratio is negative, then its reciprocal trig ratio is going to be negative as well. And that's about it. Thank you for watching, everyone.